Then I'm going to start. Again, welcome back from the lunch break. And I'm going to talk about deploying Perl apps using Podman and Ansible and a very little tiny bit of Make. At the PerlKohaCon, is it big enough? No. Oh, it's very big. At the PerlKohaCon in Riga, the last one, I did this talk about deploying Perl apps using Docker, GitLab, and Kubernetes. You can read about it here. That was a very big and enterprisey and cloudy deployment process, which was also very complex and expensive. So now I'm talking about another approach for another project, which is not very cloudy and not very enterprisey. It's for the Verband der österreichischen Volkshochschulen, which is the Association of Austrian Adult Education Centers. So it's a little bit like libraries. Yeah. And they have a bunch of web applications, mostly Catalyst. Those are the names of some of those applications. Search thing and single sign-on. There's also a Drupal content management system and some other stuffs. They have not only web applications, they also have stuff like beamers, mailer, background job processes, and whatnot. Everything is running on a Postgres database. You also use Elasticsearch and Redis. So it's like a small project. I mean, it's not tiny, but it's not like huge enterprise thing. And the project is completely non-tech focused. They don't care about tech. They just want to use it. And they have no dev team, no deployment, no DevOps team, nothing. They have about 100 hours per year time budget for a little bit of maintenance and features. So they don't want to use Kubernetes. They also have no proper infra tools like GitLab. Instead, we use Gitolite, which is a very small Git server. And we're piggybacking on some other projects, Request Tracker for issue tracking. And there's no container registry. Okay, so if you know Docker and stuff, no container registry, which is a little bit annoying. Some credits. Most of this stuff was actually implemented by Fahad Shabazi, that guy, together with me, but he did like most of the actual hard lifting. But like the concept is all my fault. He just did what I told him. So the plan, the overview of this talk is I'm going to shortly talk about containers and then about the deployment. So how the code is actually run on the server. So what's the finished state, which is talking about container and Podman and systemd. And the second part is about deploying. How do we actually get the code onto the server? So this is going to be Ansible and a very little Makefile. The deployment, again, it's like a small system. So there's one node, so one server. Each of those services runs in one container. The services can talk to each other or need to talk to each other. There's some shared infrastructure, and it looks like that. So like one box and some other boxes. I didn't draw the arrows. You can imagine that those star things are things that we wrote, and the other boxes are open source projects that we just use. Okay, so that's like very run-of-the-mill architecture for a small thing. And for the deploying, we want to make sure that the server and all its components are in the same state. Then we want to build a new container, get the container and all the config and all the assets onto the server, and then restart the thing. Okay. So I'm not talking about Docker containers. I'm just talking about container because there are other container platforms than Docker, and it's like. And I mean, I guess most of you know it, but for me, this was like a good explanation of what a container is. It's the magic box that contains an operating system and whatever else you want, and you can install it without interfering with your laptop. So you have like 20 different containers on the laptop on some machine, and each of them is nicely separated from the other ones. And those Docker containers, they are also lightweight, not like previous versions of containers or virtual machines, which could be quite heavy. So Docker introduced some smart concepts to make these containers not so heavy. Here's a very simple container file that you please never, ever, ever should use like this. It's just to illustrate what a container file looks like. Usually you start from, so you have like a base, another container that you start from. In that case, it's a Perl 538 running on Debian Bookworm. So I'm reusing an existing container file and use that as a baseline where I start from. Then you run some update scripts, in that case, to install the Postgres client. And then I use cpan to install cpan minus for whatever reasons. Copy the cpan file from this copy line copies the CPAN file from your host machine, from your laptop, into the container. So that later on in this line here, sorry, I didn't do the highlighting here, you then can run inside the container to install all of the dependencies. And that's like the worst line of all, which if you see this, just don't use the container file using that, because that copies everything that you have in your current working directory into the container, including, for example, your .git directory, which results in very big and very stupid and annoying containers. Okay, so don't use it. And then you can have just a command, oops, wrong button, wrong direction, a command which actually starts whatever you want to do. In that case, it starts a starman plug CGI script running a server. Again, never use copy. This is a very bad example. It's just a very short reminder of how a container file looks like. I did a talk on writing a good Docker file for Perl applications, which you can find over there. I also have a blog post on how to set up a nice Docker file using Perl 536 with Alpine and a working SSL configuration. If you want, we can later on take a look at some more advanced and nice Docker files, but sorry, container files. Like the big container benefits is you have actually the same setup on your development machines and your production machines. I also find it quite nice that you have some sort of automatic documentation of the installation and setup process, because in the Docker file, you have to write everything down. It's not that you can SSH into the machine and run something manually and then forget about it. And there is also no need for stuff like Carton or locally Perl Blue, Perl Env or whatever, because the container is already contained. You don't need to use any further tools to further contain your installation from the operating system, because it's already contained in the container. There's also this thing called Docker Compose, or also Podman Compose, which I like very much for local development, because it allows you to start multiple containers, and the containers they depend upon, and does networking and a lot of other nice things. Makes it very easy to set the environment for each container, handle volume mounts and networks. Come to that. Yeah. So one thing about those containers is they are ephemeral. They don't actually store any data. If you can, every time you start the container, it's fresh and it doesn't remember anything. And you but you still, of course, don't want to have your database passwords or connection parameters or whatever hard-coded in the container. That's obviously bad. And for example, you want different ones for different environments. You don't want your local development machine connecting to your production database. It should be different ones. So, like, the easiest way to do is setting environment variables. So instead of, I don't know, hard coding it, you just do something like that, where you connect the database using some environment variables. And then when you start the container, you just set the environment variables on the command line. I mean, that's nice for a little bit of testing. Okay. Was it the question or just a? Oh, okay. Another thing is you can also, if you have a lot of environment variables, this gets a little bit unwieldy. So you can put them in an environment file, just a file, and then use that end file by just pointing your container runtime to say, please use this end file where you have all of the environment in it. And then you have different environment files for different deployments or different things. Volume mounts, it's another thing that you could do. For example, you can also include a default configuration file into the container via container file. That's especially mostly needed for stuff like Catalyst applications. They very much like their config file. And then you could use a volume mount to replace that file with a different file from your host. Okay. Volume mounts have a lot of other uses. The most obvious one is that they allow persistent storage of data. Because instead of storing everything into the container, you, from the host, mount a volume into the container, write stuff into it, which is then also available outside on the host. So when you remove the container, start a new one, mount it again, you still have the data. Okay, so that was like part 0. So let's take a look at the actual deployment. So how is this looking on the server as it's running now? So as I said, we're talking about Podman. Podman is a pod manager. It's very much like Docker. It's, I think, 100% the same user interface. There's this joke that you can just alias Docker to Podman and continue using all your Docker commands. But you can just also use Docker. One big advantage is that it's rootless. So it's not required a root user. Docker has to run as root, which is a little bit annoying and a little bit of a security risk potentially, because if it's running as root, maybe something from the container can escalate and access your system and do annoying stuff. And there's also no daemon needed. If you run Docker, you always have the Docker daemon running on your machine, and the Docker daemon checks which containers should be running and whatever and whatnot. Podman doesn't do this. It just doesn't. You have to care on your own which containers are running. For example, by starting them via systemd services. A pod is a collection of containers sharing a network. That's, I don't know if any of you ever did Kubernetes. Okay. So, and all of the containers in one pod, for example, can talk to each other via localhost. So you don't have to do any complicated bridging or rewriting of networks or whatever. All containers in one pod can just talk to each other, which is actually, as I hinted, the same in Kubernetes. But usually when you use Kubernetes, you always deploy one service into one pod most of the time. You don't have to, but it's what's usually done. But here we're using like one pod, and into this one pod we deploy all the services. So here's the live demo. For example, Podman has this thing where I can just say, okay, Podman ls, so list me all my pods. So on that machine there's one pod named KB for knowledge base. There's 16 containers, it's running since 5 months, some information. And then you can use Podman PS to get a list of all the pods that are all the containers that are currently running, using here -f pod equals KB. So I only filter them of this one pod, which is pointless in that example because there is only one pod. But if you have like several pods on one machine, you could limit that. And then you get a list of containers, which is not very interesting. Yeah, just see the container ID, the image that's used, where you here can actually see some of the, which button is it? Some of them are like external ones, which were pulled from Docker Hub or directly from the Elastic Docker container, and those are the ones we wrote our own, which are our own containers. This one, the pause thing, is inside each pod. Podman starts one special container to do some management stuff. And the pods also have always have a short name, so we don't have to type this horrible thing in. And also the name is persistent, and the container ID not so much. Here, for example, you can when you want to enter one of those running containers, you can say Podman execute and the name of the thing, and then the command you want to execute. So in that case, I want to run bash inside the container so I can get into it. So now you're in the container, which is in my head the same as SSHing into a remote machine, but now you're accessing the container. And then you can look into it, and it's just like a machine. So you see something that looks like a Catalyst installation. And then in the container you can just run a command, plug up, and then the server starts up. And then we can, for example, enter another container. So here we were using the container called statsweb, but now we're entering this container, doesn't matter. And in the container, we can now try to access the other container by just doing a curl request to localhost and some path, and we get back some data. And you have to trust me that that's actually the other application that's answering here with some status data on its status. Yes. Okay, then there's systemd, which is a system and service manager, an init system used to bootstrap user space and manage user processes. It's like 10 or 12 years old, and there was a lot of critique about it. It's similar to something like systemd, initd, runit, daemon tools, and like a lot of other products that you can use. Basically, it's the thing that starts when your computer starts and then starts the other processes and manages whatever is running on your machine. And it can start services, which is what we want. So here's one of those service files, which looks like this. let's only take a look at this part here, which is access start. So when you start the service, this command happens. So you use Podman run to run this Podman container. And give it a name. Here you can see how you do this volume mount things. So I'm using mount of type bind to take the source file, which is a file on the host machine, which is the config file for this environment, and mount it, like copy it into the container in this other path specified by target. So whatever was in the container at this location is now replaced by that file. Here's the same thing. Use another mind bound, but here we mount a directory, so we can store files which were uploaded to on the web interface. They're uploaded into the container, but because this directory is mounted onto the host, if you stop the container, start it again, mount it again, we still have the files. If you don't do this, you stop the container, all the files are gone, and your users are probably not very happy. And then again, here we specify the environment file. So here's the file where all of the environments needed for this application are stored, again, on the host system. The rest is just internals of daemon tool, systemd, which I'm not going into much details now. If you do that, then you can, and it's running, you can give me the status, then you get some information on, yes, the service is running since that amount of time, takes so much memory, blah, 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 some stats. You can, of course, just restart the thing, stop it. And the nice thing is also you can still just call regular Podman commands on it. So there's like one way to interact with it is using systemd and the system unit file, and the other one is you just still can call Podman, for example, to get the last 3 lines from the error log. So now we have our deployment, which is a bunch of containers running in a pod managed by Podman and controlled by systemd. How do we deploy the changes? So the one thing that we found was annoying is we don't have a container registry. So usually what I used to do is you push your containers into a container registry like this. So you build a container, you tag it with some name, and then you also tag it with like the external name in the container registry. And then you push the container over there. And then it's uploaded into the container registry and available for download, which you can do like this. You can say Docker pull on another machine. So that's like on the live machine, you can just pull and get the new container. But this needs this registry thing, which is a server running somewhere, handling stuff, doing authentication. That was too much overhead for that project. And we don't want to use a public container registry, which also exists. Of course, you can go somewhere and rent or get one for free. But as it's an internal project, we don't want the source code publicly available, so we don't do that. Luckily, Podman and also Docker have this thing, save and load. You can say Podman save, give it a file name and a container, and it will just basically dump the whole container into this tarball. And then you can use Podman load, point it to the tarball, and it will load the container image. But where we're going, we don't need files. We have pipes. So what we do here is we say Podman save this thing, zip it, use PV, which is just a progress bar in pipes. We SSH to the server, and on the server we unzip and use Podman load. So this is like one line where how we can get the container from this laptop onto the server without any central container registry in between. Okay, now I'm going to talk a little bit about Ansible. Simple IT automation, there should be a new line in here. It uses YAML to run commands via SSH on other servers. Comes with a lot of weird slang, which took me ages to somehow understand. Playbook, inventory, tasks. I still find it a bit confusing. You can watch the talk by Rake, Automating Perl with Ansible, if you have a time machine, because it was like yesterday. Or you wait a little bit until it's available on YouTube. Or you can use Rex, as shown by Ferki in his talk, Rex use cases and patterns. You also need a time machine. And but not a strong one because it was like 2 hours ago. Or again, you wait until it's available online, or watch the slides. I actually probably like Rex more, but Farhad, who did the actual implementation of this thing, he preferred Ansible, and the option was let him do it using his tool or me do it, so it was his decision. So what you have in Ansible is a playbook, which is a collection of tasks. You have an inventory, which is a grouped list of hosts, looks like this. So you can say, okay, you have a node, which is a server name, and for example, you have something called DB, which is a list of other servers. It's just like a way to group and label the hosts where you want to deploy to. The actually interesting things are tasks. So this is like a shorted version, where I just list all of the tasks you want to do. You want to set up some directories, copy some files, set up the service unit file, and then start or stop the service. If we expand this a little bit, so this is like one Ansible task, which has a name, and then it gets horrible. Because here you have file, yes, and what this actually means, it's running the module called file. And there are a lot of different modules, so all of those tasks look different, at least to me. And the second horrible thing is this with items. I mean, we talked about it earlier, and you mentioned in your talk. That's like programming using YAML. It's because you want to loop over all of those things, and this is YAML is a static configuration language that just describes data. They always invent ad hoc weird formats on how to do loops and conditionals and whatever, and you end up with horrible, unintuitive stuff like that. So what this does is it takes all of those files, which are files on my machine in the repository, and copies them somewhere there, I think. Yes, item path. I'm actually not sure. Yeah, no. Oh, sorry, it setups directories. It's not generating file because here it says state directory, even though it's a file module, because it says here state directory. It checks that each of these directories exists on the server. And if they don't exist, it will create them using the mode that's listed over here. Now is the step that actually copies the file, which is basically the same. So you again have this copy module, I guess, which has, again, items which copy this file from here to there. Now, from here to there, from source to this place. So this is the file on my laptop, and here where it should be on the server in the end, blah, blah, blah. And this notify thing at the end says, okay, if this action happens, so if the file was modified, afterwards, later on, please start these tasks, which will in the end restart the application. So if the configuration file was changed, we need to restart the web server. Here's another, even more complex file. It's using a template. So what that again is doing is it's copying those source files again onto the server. But oops, wasn't there? No. But it's using a template, so the file is not just a file, but the file inside contains it's a Ginger template, contains stuff like that. We have like a templating language in the file. So you say, I mean, you can read it. For each line in this data structure, generate this one line. Okay. Then you have some other place in this horrible YAML labyrinth where you can define this command. So in that case, we have those 3 values in this array. And in the end, if you take these values and run them through this template, you end up with this snippet. Okay? Clear? Yeah. Okay. Yes. And if you now want to run it, it gets more complicated. So you have this script called Ansible Playbook, which runs a playbook. The playbook is called site YAML. You can have a lot of different playbooks. And in the playbook, you have specified the tasks you want to run. You say you want, that's the file that specifies your inventory. So here you have the list of your hosts. You could have maybe a different list for production and for staging, for example. I like different ways to do it. And you want to, in that case, I want to limit it on only hosts that are in the node group. Okay, so you want to deploy it on 5 servers, you put all those 5 servers in the node group, and then this command will run on all of those servers. And additionally, you can have some things like tags where you can additionally filter and limit your stuff. So I don't want to run, because this playbook could be huge and do a lot of stuff, but I only want to run stuff that's relevant to this statistics module, which is the name of this application. And there's also this nice check thing, which says, okay, only try it out. Don't actually change anything, just tell me what it would do. Try run. And what it would do is something like this, which is again a little bit shortened. So it would do all of these things, make sure all of the directories exists, copy the files, blah, blah, blah. So in that case, it seems that everything is already okay, and the server is in an okay state. I find this command nicer, and it took me a while to find it. List tasks, where you can just say, okay, again, for some tags, and then it will just list you all of the tasks that it will do without even doing it. So the dry run takes ages because it has to actually SSH into the server, do the stuff, try everything, and then roll it back, I guess. But this is just instant because it just takes a look at your local YAML configuration and tells you what it would do, which now helps me to figure out what will happen if I run one of those cryptic Ansible commands. So if we want to actually deploy a change, I changed some code. I changed the expiry of the session from 10 hours to 8 hours, just to have some thing in here. So that's like the diff of one thing. And then I run the playbook. And then you get a lot of output in here, which I shortened a little bit. So again, you see in the first thing, everything is okay, but then now in here, you again see the diff. So it tells you, okay, on the server, we have a different state than on the machine. That's the difference. And then here it will just change it. So now the file, now it uploaded the new file onto the server. The next task is again okay. And then in the end, here you see that it again changed something because it restarted the service. And well, the very small makefile thing, because I always forget all of the Ansible commands, I put them into a makefile. So I have a makefile like this, which also does a little bit of other things. Make files like that. And you have to treat them from the, yeah. So I can just basically say make starts deploy, and if I do that, this thing will happen. So it will go into the container. No, it won't happen because it has a dependency. Because makefile has dependencies, so it will first do this. Oh, another dependency, so it will first do that. So it will first build the container, then do this pipe thing to upload the container, and then it will actually run the Ansible command. I guess I could also put all of those makefile commands into Ansible, and I guess I could also put all of the Ansible commands into makefile, but that's like, that seems like a sort of sane mixture in here. Yeah, the makefile is, not, as I said, not very fancy or complex, but it's more reliable than command line history because you can check it into your repository, you can send it to a colleague, and sometimes I just open the makefile and, that was the command, and then just copy and paste one command out of the makefile and run it. Yeah, so altogether, so you hack locally, you make a change, edit some config, build a new container. Because you don't have a container registry, you just pipe the new container to the server. We make sure the server is up to date via Ansible, and if any changes need to be applied, Ansible will do it. Then we, again, via Ansible, we restart the thing on the service and profit. Well, okay, no profit because that's a non-profit project, but yeah. So my summary for this is containers make everything so much easier. I mean, before I used Docker containers, I always had like different Perl brews and local libs, and it was very horrible. And then I had one database version on the laptop installed directly, and then different projects would need different versions of the database, and all of this just goes away with containers. Podman provides a very nice way to manage container and run a group of containers. It's really nice. I also guess it takes less resources than Docker. It's a project. It's currently, I mean, it's owned by Red Hat. But I'm not sure of its history. Yeah, so but it's also open source and freely available and everything. And systemd is actually quite nice if you figure out how to write these service files. But I also never figured out how to write old systemd init scripts. I also found it very annoying. And some people criticize it because it's too big and does too much. You can also run cron jobs via systemd, and I don't know, you can do a lot of stuff. But it's nice. And what's also nice is you can use systemd also as a user. So you can have your own service files, which are not related to root. So you can set up, like, that's not in that project, but another project, which uses a similar setup. We actually have unit files that just belong to the production user. We have a production user and a staging user on the machine, and each of those have their own system units, and only the user can run the services. So there's like no root and sudo involved at all, which is quite nice. Yeah, and then of course you should automate all of this process as much as possible using whatever tools you want, for example, Ansible or Rex or Makefile. Any questions or discussions? Or is everybody in a comfortable post-lunch coma? Okay, then thank you. Yeah, you may applaud. I have a very small bonus thing. I mean, because I was a bit unclear on the things. We actually run the same thing also in GitLab. So we have another project, the other project I was talking about earlier. We have basically the same setup I showed you now, but instead of me running it on my laptop, we moved it into GitLab, into the CI and CD part of GitLab. So GitLab uses this thing called GitLab CI. Yet another horrible YAML file with conditionals and loops and whatever. It's like, please just use a stupid programming language for that, but no. So what this does is, that's a task a job in GitLab, just named production, deploy production. It takes here, so that in that project we do have our own registry, because GitLab, you know GitLab, yes, like the thing, okay, provides its own container registry. If you use GitLab, you not only have like issue tracker and Git, but also a container registry, which is quite handy. So, and in our container registry, we have an Ansible image, because I don't like to pull from the public repositories all the time, because sometimes they just say, you pulled enough, fuck off, and then your pipeline fails. So that's just like the regular Ansible container. Here we just basically copy the SSH key that allows access to the target server into the container, which is, you can do it quite safely because GitLab provides this secrets service where you can have environment variables available for the thing. And then the script that we're running is, again, a makefile. So we're using GitLab to put an Ansible container to run a makefile. Oh, no, and then use make to run Ansible. That's the way. So this thing here is just make in this directory and some variables. And if you take a look at the makefile, which is included in the repository, which is checked out by GitLab during GitLab CI, we just call this Ansible playbook, which is using some stuff to basically run the thing we did. And then this looks like this. So this is how a pipeline looks in GitLab, where we have the different steps. What I showed you was this step here, which then again looks like this. I mean, you don't have to read it, it's a screenshot. But one nice thing is this thing here. It took 26 seconds, which is quite fast. I mean, that's only the last step of the deployment, but usually if you don't have to rebuild the container, and because it didn't change anything of the dependencies, and you only changed a little bit in the code, a deployment takes, I don't know, 40 seconds or something, from push to running on the server. Yeah, so it runs all of the stuff, and in here you see the output make calling Ansible, and here you see the output of Ansible, similar to what we've seen earlier, inside GitLab, triggered via a CI action. So you don't have to actually type it on your own machine. And that's so fast because the only thing it actually do is to pull the new image, because in the previous step in the CI pipeline, we build a new container image, put it in the container thing, and this just pulls and restarts. Because in that case, there was no real change on the server. So that's also quite nice. So if you have even if you have a proper infrastructure like GitLab, you can still use those basic tools. You don't have to go all in on cloud and Kubernetes and whatnot. So that's finally it now. So thank you again. Yeah, there's a question. You have the microphone still? Oh, give you. Where is it? The microphone? Oh. Okay. Here it is. Okay. Sorry.
In fact, I have a question about this last session. I see that you use GitLab Community Edition. Do you think it's enough to use in a production way? Because in fact, GitLab do this type of thinking that put some core inside the Community Edition, but some places only on enterprise. It's possible to switch between the situation. How do you find?
So the question was between the different versions of GitLab. Yes. GitLab, in fact. Yeah. I mean, so we are running our own GitLab instance locally, but we're using the free version. Yes. And I don't know if everybody knows this, so there are like different versions of GitLab because they have this. They provide a free version, hosted or self-hosted, and then they have different versions which have more nicer and cooler features, but they're not available unless you pay. Yeah, and I don't find the features that they provide for money worth it. Or I actually would find some of the features quite nice, but I find the pricing scheme so annoying because they charge per user. And so I think the cheapest paid version is something like 10 or 15 euros per user per month, which would be maybe okay, and maybe they changed it, but the last time they didn't, because I have a lot of fake users which aren't really humans, but like bots or whatever, and doing stuff. Yeah. So I never used any of the paid features from GitLab. Sometimes I search for something and said, okay, I want this, and then I find the documentation and they say, yeah, we have it in the premium version or the gold version or whatever. And what they sometimes do is that after 1 or 2 years, they make it available in the free version. Not everything, but like I think all of the core stuff you need is in there, and in the premium version you have better project management tools and stuff like that. If that answers your question. Okay, perfect. Okay, then not again. You know this automatism. If the speaker says thanks, everybody claps. You can thanks. Oh no, thanks. Oh my God, it's never going to end.